All right, so remember, half the test, well, I guess you know this by now, half the test is the strategies and half is solving equations. So let's talk strategies first. All right, so what are we gonna do with something like this? What do we always have to do first here? Z equal to 0. Good, we gotta put it into standard form, right? So we'll subtract 8. That's gonna give us 4x squared minus 4x plus 9 equals 0. Okay, is there anything else we can do to simplify that? We're kind of stuck, aren't we? What's the problem? A is 4, right, and then C is 9, so we can't divide conveniently by 4, right? So then what's that mean? If we're just trying to find a strategy, if we're stuck with that being a 4, what do? Quadratic formula, right? Yeah, we don't want to. I want you to get rid of that. We don't want to mess with trying to factor. We'd have to do bottoms up. We don't want to try to complete the square. That'd be hard, right? So if we're stuck with an A that's greater than 1, or that we could even just say A that's not equal to 1, right? Then we go quadratic formulas, right? Okay, good. What about here? First step? Z equals 0. Good. So same as before. We've got to add 2x squared, subtract 6x, and add 8. So we end up getting 0 on the right. Notice the 8's cancel here. And so we get 5x squared minus 15x equals 0. So this is one of those types where these are easy, right? We've only got 2 terms. We don't have 3 terms. So we don't have to worry about finding magic numbers or any of that kind of thing. What do we do if we've just got 2 terms? Talk to me about this one. We got to just factor, right? I mean, we can't isolate x. If we could, this would be pretty easy, right? But we can't. It'd be even easier, I should say. We can't. So the only thing we can do, if I've got 2 terms and I can't isolate x because there's more than one x up here, well, that means that there's an x in both terms. Everybody agree? Right? So at the very least, I could factor out an x, but maybe more, right? So we want to factor out a greatest common factor. Okay, so what's that going to be? 5x, good. And what's left behind if we do that? If I divide 5x squared, which is my first term, by 5x, what do I get? X. If I divide 15x by 5x, that's my second term, what do I get? Okay, good. So then we've got this thing factored. I know that looks a little strange, and people sometimes wonder about that because this doesn't look like a normal factor, binomial. It's just a greatest common factor. We call it a monomial. It's only got 1 term. But it's still a factor. I've got 1 factor there and a second factor there, and I'm going to set each one equal to 0 and solve, right? So then by the 0 product property, I know that the product can only equal 0 when either that one is 0 or that one is 0. What are my solutions going to be? Yeah. When is 5x equal to 0? When x equals 0, right? X minus 3 is 0 when x equals 3. So those are my 2 solutions, right? I mean, in this problem, I guess we finished the whole thing. Really, what were they looking for here, though? In this, I mean, this wasn't a solve question. It was a find a strategy. So what did we end up doing? Factor and 0 product property. Yeah. Factor 0 product property. All right. How about this guy? Add 6. Well, we can push everything over here, but let's this time let's just add 6 to both sides. Which gives us 0. On this side, I get negative x squared minus 4x. What's that? Minus 10. Okay, what's the other thing I need to do, though? Got to make it positive. So we'll multiply both sides by negative 1. So that term becomes positive. That term becomes positive. That term becomes positive. So are there magic numbers? Multiply to what? 10 and add 2. Do they exist? No. No magic numbers. But what could we do? What are really my options here? Complete the square is probably the best option. The reason we would complete the square, we've got a 1 there and an even value for b, so why not complete the square? I mean, second place would be quadratic formula. And that's, if you like quadratic formula, and that's the one you want to do for everything, you can. But when you're selecting the best method would be completing the square. Fewest steps, okay? So if we were going to complete the square, then what would we do? Remember we have to push the constant to the other side. And what's the number that we're going to have to add to both sides? We'll do this in a little different order. We're getting better at this. I think we can probably work one step ahead now. What's it going to be? 4. And how do we get 4? Okay, because the b, we end up with 4 divided by 2 is 2, and 2 squared is 4, right? So then, now we've created a perfect square trinomial, something that's going to factor the way we want it to. On the right side, we just get -6. What's that going to factor into? What are the magic numbers that multiply to 4 and add to 4? 2 and 2. There it is, right there, right? There's the number we're looking for. 2 and 2. So x plus 2 squared. Okay? Last 2 steps. Square root. If I square root both sides, what am I going to get over here then? If I'm square rooting. Square root of -6. What do I have to do? Can the square root of 6 be simplified? No, we're stuck with that, aren't we? So we're going to get plus or minus the square root of 6. But what about that negative? I. And then last step? Yeah, just subtract 2. Good. So we end up with x equals -2 plus or minus the square root of 6i would be my solutions. And then, you know, we did the whole thing, right? But really this question was just asking for complete square, right? Okay. Pretty obvious here. What are we going to do? Chris, what are we going to do there?
-80.
Isolate the variable. How come? It's only a single x. Remember what we always say, if you can point to a single x, then you can isolate it, right? Just reverse order of operations. So right back at you then. So we know we're going to isolate x. Now you tell me what are the steps going to be to get that x by itself?
Probably up to -80.
Subtract 8. Good. And really, if you ever forget, remember all you're doing is just going in that direction to isolate. Bottom to top of order of operations. So we subtract 8. Good. Okay, now what? Square root. Very good. And if we do that, we get -2x plus 3. And let's look at that 72. How could we factor that conveniently? When we think of, and when I say conveniently, our goal is we'd like to write down a perfect square times something else. We could do 9 and 8. That would work. And then 9's going to break up into a couple of 3's. What about the 8? But we could actually go a little further because there's a perfect square in that one too, right? 4 is. So what's the 4 break up into?
2.
Okay, so then what do we get? 72 is going to simplify to what? There you go. Good. So we're going to get plus or minus. We get a 3 and a 2 outside, which multiplies to 6. and a single 2. So we could have done this a little easier if we'd seen 72 is 36 times 2. That would have been the easiest, right? Because 36 is just 6 squared. Okay. But either way. Okay, last 2 steps. Subtract 3. And then divide by negative 2. But remember our rule with this. When we divide by negative 2, we'll just divide these separately, right? Because we know they're not going to combine. What about the plus and minus term? Do I have to divide that by negative 2? And I just divide that one by positive 2. Good. And then we would just simplify. So negative 3 over negative 2 is positive 3/2. 6 over 2 reduces to 3 over 1, doesn't it? So we just end up with plus or minus 3 radical 2. Okay. Make sense? Questions on that? Okay. So here we're just going to subtract 4x. Everybody agree?
Yep.
Say it again. I mean, we could, but are there magic numbers? Good. Negative 3 and negative 1. Now, sometimes you can just be certain that there aren't, right? But if you're at all unclear about that, unsure, I would say make the brackets and just see if it works. If it doesn't work, all you have to do is cross that step off, right? But just try it. And I think it helps to play the sign game. If they're going to multiply to a positive and add to a negative, what do you know about the signs? Both negative. Good. And then it makes it easier. Then you can think, oh, okay, well, 3 and 1 work, right? So what would my zeros be? 3 and 1. Good. So this was a factor and 0 product property one, right? Okay. What's that one going to be? Well, we'll need to do this one. Isolate x, good. You can see we got a single x right there. So isolate x, good. And what about this guy here? So if we add 2x, everybody agree we get x squared plus 8x plus 18 equals 0? Right? Okay. What do you think? Bryce, any ideas there? Say it again. You can't factor it, you're correct, you can't. Right, numbers don't multiply to 18 and 8, so then what would our next option be? Complete the square, and that's a good candidate, right? Completing the square makes sense here because we've got even b and a is 1, right? So we complete the square. So we'll just push that 18 to the other side. Now what number is going to go here, Julian? For 16, there you go, good, because we're going to do half of 8 squared, right? So we're going to get 16 there, and we get that from 8 over 2 equals 4, and then we'll square it to get 16. Good. Okay, so on the right side, that simplifies to -2. On the left side, what's that going to factor into? Of course, what are my numbers that multiply to 16 and add to 8? 4 and 4, right? X plus 4 squared. Lauren, last 2 steps. To solve for x there. Because now I can just isolate it, right? So square root, good. So that gives me my x plus 4 equals, what do I always have to include with the plus or minus? Oh, shit, said it with square root. Got thinking ahead a little bit, plus or minus. And then what am I going to do with this square root of -2? I have to have an I, don't I? So the negative becomes an I. And I'm stuck with the square root of 2, which I can't simplify, right? So last step. Subtract 4, good. So x equals -4 plus or minus radical 2i. Okay? And let's see which other ones we need to do. We haven't done yet. We did one like that. We can probably skip that. Probably skip that. Okay, yeah, a couple of these. Okay, so if we add 2, I get x squared minus 15x minus 3 equals 0. Can we find magic numbers that multiply to -3 and add to add to -15? No, can't do it. So what are we going to do, Hunter? Quadratic formula. Yeah, because we've got an odd value for b, right? So we would just throw this into the quadratic formula. Now remember, the quadratic formula tells us if we start off in standard form, which we are, ax squared plus bx plus c equals 0, then what does the quadratic formula tell us? X equals, just think the song. What does x equal? Negative b plus or minus all divided by, notice it's all divided by, the bar goes over or under everything, both terms. In front of and after the plus or minus. What's on the bottom? Okay, so we could just plug and chug. So we're going to get what then? What's negative b? 15. Right, because there's our, let's identify what a, b, and c are, I guess. So a is 1, right? B is -15. What's c? -3. Okay, so 15 plus or minus square root of -15 squared. Do we know? 225 is correct. 225 minus 4 times 1 times -3. 4 times 1 is 4 times -3 is -12. So we're subtracting -12, right? All divided by 2 times 1 is 2. So we just have to simplify that. So all the quadratic formula is just plugging in and simplifying, right? So 15 plus or minus, we're going to get 225 minus a negative is plus, right? So 237 all over 2, okay? Let's see if 237 works. Do you think it will? Doesn't seem like it, does it? What, can we think of a number that goes into 237? 3 does. How do you know? Well, you're right, but you can tell pretty easily. Yeah, good. The digits add to 12, which is divisible by 3. Right, so we know 3 goes into it. 3 would go into 21 or 23 7 times with 2 left over. So 3 and 79, those are both prime though, right? So we can't simplify the radical. That's what we're stuck with. So my final answer then would just be, I'm going to take the plus version. I'm going to split these up. So 15 halves plus the square root of 237 over 2, or 15 halves minus square root of 237 over 2, right? Okay?
In the rule, can you write that as one big fraction, or do you have to split it up?
Okay, so on this one you could, but it's always safer not to. And here's why. Because what if one of these, if one of these two simplified and the other one didn't, then it would be wrong, right? Like what if this was, say this was like 16 over 8, 16 minus the square root of 237 over 2. Then that would have reduced to an 8. See what I'm saying? And the other thing is, if you have an I in there, you have to write them separately because you have to write it as a real part and an imaginary part separately. So to me, it's just always safer to split it up. Okay? Good question. We did one like that. What are we going to do there? Isolate, you bet. And then let's maybe look this one. Yeah, we'll just at least start this one. You can tell me if you want to go any further. So if I subtract 21, we get 3x squared minus 3x minus 90, good, equals 0. What could I, good, I could divide by 3, couldn't I? That's the step I wanted you to see. We can divide each side through by 3. And then what's that going to give us? So first term would be x squared, second term would be minus x, third term would be minus 30. So what do you think? Can we find some magic numbers there? And multiply. And you might want to, this one we're not sure about at first maybe, right? So you want to check this one. Just see. No, so they have to multiply to what and add to what? You gotta multiply to negative 30 and add to negative 1. There you go, good. So I play the sign game, right? You know if they multiply to a negative, you're gonna get opposite signs, one positive, one negative. If they add to a negative, the negative is bigger. And then you can find them pretty easily, right? Okay, and then so what would my solutions be? Don't confuse magic numbers with solutions though, right? Those aren't the solutions. What are the solutions? 6 or negative 5. Good. Yes, sir. Okay, go ahead. I guess this would probably be a good one to look at. So if we subtract 6, 2x squared minus 14x plus 29, what are we going to do? Let's say it again. Quadratic formula. You bet, because we can't divide by 2. We're stuck with that 2 out front, so we would just go quadratic formula. So x equals negative b, so that's going to be what? 14 plus or minus square root b squared, negative 14 squared is 196, minus 4 times 2 times 29, all divided by 2 times 2. Everybody agree with all that nonsense? Okay. So 14 plus or minus, what's this going to give us? 2 times 29 is 58 times 4 would be, what's that going to be, 232? So 196 minus 232 would be negative 36. If we just simplify everything inside there, okay? All divided by 4. So what can we do now? We can split this up. 14 over 4 is going to reduce to what? Well, I'll write it out this way first. 14 over 4 plus or minus, what's the square root of negative 36? 6i, good. Because we've got that negative, right? And then last step would just be to simplify those, reduce the fractions. So that reduces to what? 14 over 4. What's that going to become if I reduce that? 7 over 2, good. Plus or minus 6 over 4 is 3 over 2i, okay? Good, so there's our real part, there's our imaginary part for both answers, okay? Last one. So I'll subtract 28. So 40, I guess. Can I do? Divide by 4, good. So we get x squared minus 6x plus 10. What would I do with that? Factor? I mean, maybe. Can I find numbers that multiply to 10 and add to negative 6, though? I can't think of any. So if I can't factor, what would the next option be? Complete the squares and even there, and that's 1. And we've already done a little bit of that, so I'll let you just work from this point. Okay? All right. So I've got you requested. I think you're good to go. You can work on assignments or work on the practice test, or you could even start the test now if you wanted. If you want to do retake. Yep. To do what?
How do you go through to the
Oh, yeah, that's fine. Yeah, that's fine. Yep.